discuss what we talked about yesterday with the idea of having weighted grades. Okay, I think it's important to kind of walk you through an example so that you have your eyes open to the potential things that could happen while you're accruing grades in the course. What could happen to your average, maybe being contrary to what you think should happen. Okay, so I want to make sure you see that the numbers provide this information. So the first thing I want to talk about is going back and saying that our homework was worth 20%, right? That's what we were going with. Our tests and quizzes, and these are just, your traditional like chapter test, unit test, and then quizzes, pop quizzes, all that kind of stuff. They are 50%. Okay? The final exam holds a weight of 30%. Okay? That's a 2-hour exam, and it is almost a third of your final grade in this course. Okay? Which can be kind of problematic for some people because they could be going along the years and I'm doing fine, I'm doing great, and now we get to this 2-hour exam and we don't do so hot on that, and then overall you see your grade was good. Okay? So it's a situation where we got to start realizing this. It is a college course for some of you, and for all of you, hopefully it's preparing you for the rest of your college courses, for your college courses that you take in the future. And that's how things are. Okay? I've been in college courses where homework is provided, but you're told not to do it. They're trying to weed you out. Okay? They're trying to get you to fail. So you don't go to Calc 2 or Calc 3 because you can't have 60 people in the class. We want to see who are the people that are going to work and do things that are necessary to be successful. I've been in classes where that's happened. I've been in classes where there's 3 tests. One every 5 weeks, one every 6 weeks, and then a final. I've been in classes where you just kind of talk and discuss things, and homework is provided, but it's not ever graded, and there is one exam. A comprehension exam at the end, and it's do well on it, pass. Don't do well on it, 16 weeks in toilet. Okay? So hopefully we start to kind of take notice of the importance of that final exam. Okay? But I want to show you, obviously that final exam, you're not going to incorporate that in your grade until after you take it. So that 30% is something that's not going to be there for a long time. So this is how we deal with our averages, a weighted average. Okay, you're going to take your categories. So I'm just going to call my homework category, and I'm going to multiply it by its weight. So I multiply it by 0.2, right? Then I'm going to take my test and quiz category, and we'll multiply it by 0.5, its weight. I'm going to add to that then the final exam, and we'll multiply that by its weight of 0.3. All right? Then what we do, after we sum those together, we divide by the total weight used. And what I mean by that total weight used, a lot of times the equation or the formula is just total weight. I want to go through and use total weight used because if I haven't experienced that final exam yet, I haven't used that 0.3 yet, right? Does that make sense? So my divisor would not be 100. My divisor would be only 0.7. Okay? So I'll give you a specific example here. If I'm working with homework, okay, let's say I have one homework assignment, and let's say we got a 8 out of 10 on it. Let's say I have a second homework assignment. Okay. And let's say I got a 7 out of 12. Okay. Right now, that's essentially just 15 out of 22, right? And let's just say that, this is like the third day class, fourth day class, whatever. I want to see what my grade is. Well, I'm going to plug this stuff into this formula. My homework right now is 15 out of 22. I'm multiplying that by 22. Do I have any tests or quizzes? No. Okay. So I can essentially think, well, that's 0, that's 0. I don't have those things. So I just have 15 out of 22 times 0.2. But now what would my total weight be? What is only weight throughout the entire formula we're using? 22, right? Okay. And non-test quizzes. So what are those going to do? They're going to cancel out. And what's my average? Just solely based on that homework, right? That should make sense to you. If all I've done is homework, then that's the only thing my grade could be based on. Okay? So let's do one now. Let's say we get to a test or quiz. Okay? Or maybe we've taken a couple of these things and we've accrued 25 test points out of 30. Okay? So now, up here in this formula, we're going to have my homework times 0.2, but we're going to add to that now my test quiz. We'll multiply that by 0.5. Okay. Now, as a kind of running average or weighted total average right now, how much have I used? How much percentage of my weight have we used? That's a divisor. And we see then, when we calculate that, I think I've already got this up here, something similar to it. Let's see here, hold on. So it's 25 out of 30, okay? And that gives me a 79%, okay? Everybody okay with that? Now what I'm going to talk about is something that might be kind of contrary to the way you would think this would happen, okay? And I've had a lot of issues in the past with this, so that's the reason, again, why we're talking about it today. So everybody hears it, sees it, and kind of I guess that's what I'm looking for. Convince themselves that this is potential. This can happen. Okay. Right now, if I were to turn my 25 out of 30 into a percentage, 25 out of 30, I think it's like 83.3%. Okay, so 83.333. Okay. Let's say that I take another test. Okay. I take another test, test or quiz number 2. And I get an 8.1 out of 10. What does that turn into as a percentage? 81%, right? Is that currently better than my grade? My 9 weeks grade or whatever? Yeah, 81 is better than the 79 that's up there, right? Okay. But is an 81 better than the 83.3 that I have currently in my test and quiz category? No. So what I want you guys to see, what happens here, is that when I put that 8.1 out of 10 in here, I'll just do it this way, plus 8.1 plus 10, so that gives me a 33.1 divided by 40 up there out of my test and quiz points. You see that took my 79 and dropped me to 78.5, right? So even though you did better on your test than what you had overall in the course, because you did worse in your test or quiz category, it's going to drop your grade. Okay? So as you're taking tests and quiz, and this is the nice thing about Progress Book, Progress Book, the way it's set up, should kind of categorize and show you this is my category for test, this is my category for homework, this is how I'm doing in those sections. When you're preparing for a test quiz, you want to make sure that you're going to be better than what you currently have in that category, and that will shoot you grade. Okay? Is everybody all right with that? All right. If at any time you have questions about anything or questions about how Progress Book is calculating things, please do not hesitate to ask me. I can work it out with you. And
and see where we're at. All right, that being said, to grab some notes, we'll start some really simple review. Early on, guys, I'm going to take the assumption or make the assumption that since a lot of this stuff I taught to you as a geometry student, and a lot of this stuff you had seen in Algebra 2, and ultimately because it's the foundation really of what we're doing, I'm going to take the assumption that you guys can do a lot of this stuff. Okay? Now, we'll find out whether that assumption is good or bad, but I'm going to say that when we talk about the coordinate plane today, you guys can find order pairs. You guys can tell me what the x and y axes are. You can tell me, what quadrant something is in, correct? And to be honest with you, that is legitimately a section out of this college class. And there's going to be a couple sections like that where you're thinking, are you serious? That's just the way it is, okay? The way we design, so that's what we're going to do. Now, that being said, we'll touch on that stuff, but I want to get into a kind of a more kind of elaborate, more advanced type aspects of this stuff. Okay, so you'll kind of see that as we move on. Obviously, you guys know the coordinate plane, the XY axes, sometimes called the Cartesian plane. Okay, the way I was brought up, it's called the Cartesian plane. There's a French gentleman named René Descartes who was responsible for the development of it, and Cartesian is in, obviously that's the name, okay? So you can hear me say the XY coordinate or XY system, the coordinate system. When I say coordinate plane, that's okay. When I say coordinate system, that's probably not very descriptive of what I mean because there are different types of coordinate systems. Coordinate plane refers to the two-dimensional plane that we're going to talk about. Or Cartesian, I want to know they're all the same. Yes, they're all symmetry. We're all on the same page. Everybody okay? That? Now, Cartesian plane is a certain type of coordinate system. Okay? It's what we refer to as a rectangular coordinate system. Okay? A rectangular coordinate system. And kind of give you a visual of why we call it a rectangular coordinate system. If I am located at point A, right there, 0, 0, I want to get to B. Okay? I want to plot point B. What have you been taught to do as you go from A to B? How do you go from A to B? What are the first steps to do? I see some of you trace it out. You're going to move to the right probably 6 units, right? Okay. And once you move to the right 6 units, you're going to stop because right now you know that you've got the correct x coordinate. Okay, so you're going to move there and you're going to stop. And once you stop there, you're going to say, okay, now how do I change directions? I'm going to go vertical to B, right? What kind of angle did we just create here when we move horizontally and vertically back to back? Create a right angle, right? Now, some of you might say, well, I know x comes first in order to pair, but I'm accustomed to going from A and going up 5 units first. Go up 5 units first. And now I can move to the right 6. What kind of angle you got there at D? Right angle, right? What kind of angle you got there at A? It's a right angle, right? Okay. You got 3 right angles in that quadrilateral. That's a rectangle, isn't it? Therefore, we move in rectangular motion. Whenever you talk about moving at perpendicular, okay, or using perpendicular movement or anything like that, it's usually referred to as rectangular movement. Okay. Now, some of you might say, well, I don't know about that, because this is the way I would do it. I would go I'd maybe go 2 to the right, 3 up, 4 to the right, 2 up. Does that still get me from A to B? But what is this thing? If I go A, E, F to whatever point went over here, what would that shape be right there? It'd be a rectangle, right? what would this shape right here be? Be a rectangle, right? You still move perpendicular. Did multiple times, okay, but every segment that you created was perpendicular to the other one. Okay, so that's why we call it a rectangular system. So every here we say that, it's simple. Okay, moving left and right, up and down. Those are the only movements we can make. I can't go from A to B, moving along the segment AB right now. Okay, that won't happen until we get to trigonometry, start talking about angles and stuff like that. Okay. Did you guys ever, in Algebra 2, ever talk about, I don't know if it's a concept that's covered too much in Algebra 2, ever talk about this system here? Okay, this is another coordinate system. And if I want to go to the point 0, 0 to the point 6, 5, okay, the only way that I can do that now in this system is I can go straight from A to B. I can follow that path right there. Does that make sense? Okay. But the only way I can do that is to first know, ultimately, wrong direction, what that angle is, and then I need to know what, and this is something you don't need to be able to do right now, you know what that distance is. So what I would say there is, to go from A to B, I'm now going to move a length of 7.81 units at an angle of 39.81 degrees. That's going to get from A to B as well. Okay? That's our polar coordinates. That's something. Is that okay with everybody? That's still the point. B is still the point 6.5. It's much easier right now for you to deal with rectangular because it's what you're used to. But you're going to find out that there's actually a lot of algebra that those polar coordinates make simpler. Okay? You know the quadrants, 1, 2, 3, 4, you know the origin, all that kind of stuff. In this class, a lot of times, guys, we're going to be using arbitrary points. Meaning that I don't care what point P or pair is, I'm going to make them arbitrary, and I'm going to see what the general concept is, the general idea is. Okay? And you're going to see that here in a couple examples that we go through later on. All right, so we get to this. Okay? And this says, describe and sketch the regions given by each set. We'll make an analogy here with you. If, who's taking Spanish? Okay, I don't know that. All you other sign language? Nothing? Any other thing in foreign language, anything like that? Just think about English, okay? If I don't know what a comma is, I don't know what exclamation point, I don't know what question mark, I don't know apostrophes, parentheses. Going into Spanish, I don't know what tilde is, I don't even know what the name of that upside down question mark is. Do you know what the name of that is? Okay. If I don't know what those things are and what they imply to me, am I going to be very good at English or Spanish or being able to write and read and that kind of stuff? Probably not, correct? And that's the same thing in mathematics. I think it's harder maybe in mathematics because a lot of times it's not ever explained in great detail in the text what the notation is referring to. Okay? They just start writing stuff like A, B, and C up there, and they expect us to maybe know it, okay? Or to maybe do a little research on our own. I think the number one thing for me as a student that caused issues throughout all my college courses, all my graduate courses, and even high school courses, was my neglect to pay attention to notation and really get a grasp of notation. Okay? Once you get to notation, you understand the implied statements that the notation is making. It's not really all that difficult. Okay? But we got to be able to take and learn those things. So that's one thing I'm going to try to teach you guys is how to read some of this stuff. Okay? It's really not all that hard. First thing here is that these curly braces. Okay? These curly braces, so I'm talking right now about the beginning and ending curly braces. That one there and that one there. Okay? Those curly braces refer to a set. And they're just basically saying, we are going to identify a set. Okay? Now you guys might not know what a set is, but a set is simply a collection of things, a collection of objects. Okay? We could ultimately say that, if we were to
put your guys' names in like a roster. Okay? That is a collection of things. And just leave you as just in this class. It says classroom. The names of the students in this classroom is a set of objects, a set of things, isn't it? If I go to Baskin Robbins and I name out all, 31 flavors of ice cream, something like that. Those flavors are a set of things. If I list my favorite colors, red, blue, green, it's a set of things, right? Okay. We'll talk a lot about sets this year. They're just collections of objects. Okay, the ones that you guys are probably most familiar with, integers. You know what integers are? 0, 1, 2, 3, 4, 5, 6, and their opposites. That's 7 numbers. They all have similar characteristics and define to be those things. Okay? Rational numbers. Those are everything written in A over B, and B cannot be 0. That's a set of numbers. Okay? Whole numbers, natural numbers, all those irrational numbers, rational numbers, complex numbers, they're sets. They're groupings of things. Is that all right, everybody? So what we see right here is that we're going to identify what we're talking about a set. Now, the next thing is we're going to name or we're going to describe what that set looks like. So what this is saying here is that our set is going to look like some ordered pairs out of the Cartesian plane. They're going to be x, y values. Okay? Okay with everybody? We describe what they're going to look like. Okay? Now you see a vertical bar. Okay? And that vertical bar, that vertical bar right there, referring to the phrase substance. Okay? So we read this. The set of ordered pairs such that. And that's all notation. That's just knowing essentially the grammar of this aspect of mathematics. Okay? Now we get to the actual math one. It says that x is greater than or equal to 0. X is greater than or equal to 0. That's the only requirement that we, sometimes they call it maybe a constraint, sometimes they call it a requirement, a condition, okay? But that's what we're looking at to create this, this region that we're going to sketch here. So I'm looking at x and y, so it tells me try to be dealing in the coordinate plane. Okay? But now it says my x values have to be greater than or equal to 0. So first I'm going to do is say, can they be 0? Can my x values be 0? Okay, so my x value could be right there. The point, the ordered pair that I'm talking about could be right there. But if it's 0, that's not the only place that x is 0. Could x be 0 right there? X is 0 right there. And I can do that because there's no requirement on what y is. Okay? So x has to be 0, but y can be, well, that means then that in this sketch, I have to include all those points right there on the y-axis, right? Because all those points are to go through and list every single one of them. Each and every one of them is going to have an x value of 0. So that needs to be part of this group of objects. Okay? Now, if x is greater than 0, you just kind of play this game where, okay, well, what if x was 1? Then it could be here. That point, you talking about that ordered pair. Might be talking about that ordered pair. So that x value 1, that one does, that one does. So I could be talking about that line there, right? But if x is greater than 0, the first one that's greater than 0 is like 0.000000001, right? A lot of zeros and a 1. So essentially, there could be another vertical line as close to this one here as possible. And then there's going to be one close to that one as possible. Does that make sense, everybody? So you guys realize that all of these points in the first and fourth quadrant, including the ones that are on the y-axis there, all of those points are points in which x is going to be greater than or equal to 0. Does that make sense? Okay? It's, you know, if I were to give you the picture and ask you to come up with a description of what that grouping of ordered pairs looks like, it's probably easier to go that route. Picture and then write down what the description looks like, or what the algebra. Okay? I think reading the algebra and going into the picture is a little harder because we don't necessarily know that notation real well. Okay? So if I look at part B here, it says x comma y such that y is greater than or equal to 1.
x comma y such that y is greater, or sorry, y is equal to 1. So get my x and y axes again. Are there any requirements for x? No, so x could be anything. So maybe I just start listing a couple of these things. X could be 0, but y has to be 1. X could be 2, but y has to be 1. X could be a half, but y has to be 1. X could be negative 3,000, but y has to be 1, right? Okay. X could be negative 2 times 10 to the negative 13th, but y has to be 1, correct? That's what we're saying here. So the idea then, if y has to be 1, it could be all these kind of points, right? And if x can be anything, all those points start to fill in the gaps eventually. And we're just looking at that line of y equals 1 to be the set of ordered pairs that is described. Is that okay? All right. The last one, we can kind of use what we just came up with in B to help us with the last one. If I just look at this condition, y has to be greater than negative 1, right? So I'm going to find negative 1 on my y-axis. It's terrible. So there's negative 1. And my y values have to be bigger than that. Okay? So that's why it's dotted. I can't really use any point that's on there. Okay? But there's no condition for x, so x could be anywhere left or right. But y has to be above negative 1. And this part here then is saying y has to be below 1, correct? So let's make this dotted. Maybe there's my value of 1. And y has to be below that. So every ordered pair that I come up with has to have a y value that is somewhere between 1 and negative 1. X values can be anything. Okay? So then if I'm going to incorporate and talk about all of those points, shape between those two lines, and now I've got all those points. Does that make sense? We'll do this several times over the year, talking about these sets, looking at regions like this. The reason you have to have this notation is in that blue region, there's an infinite number of points, right? There's absolutely no way for you to physically write every one of those points out from the list because you would die doing it, right? Somebody would pick up a pencil action and they would die. The entire world would be born and would die doing that before the list ever came out. Because of how infinity is. Okay, does that make sense? Okay? So we have to have a concise way, a quick way of writing that, and that's the notation we need to do. Okay? And the nice thing about it is that it's consistent through all of mathematics, that concept, and using those infinite objects in that manner. So on the PowerPoint, guys, what's going to happen a lot of times when I use these PowerPoints, sometimes I use ones that are already developed, use my own, sometimes I use PDF. This one's already been developed. What they do is they'll present you a question, we'll work through it, within the next 4 or 5 slides, and then working through it. And I'm not going to read those again to you or spend time on those again with you. So then we'll get to this stuff here. So talk about the distance formula, and this is going to be something that you guys are familiar with. Okay, you guys remember the distance formula from geometry and algebra? Okay, just go ahead and shake it up and down. And hopefully maybe some of you remember the way that I kind of describe the distance formula to you in geometry. And I'm going to make the argument that maybe in geometry, because it was 2 years ago, we weren't all that mature. Maybe we were mature, but maybe we didn't have the math background yet or the experience to really understand where the distance formula came from. Okay, so this is what I want to do. First thing I want to do is I'm going to just talk about something really simple. All right, if I just have a strict horizontal number line, it could be just a vertical number line as well. It doesn't really matter. But if I have this point here, or call this arbitrary point A, and I have another arbitrary point over here, call it B. Okay. Now I do have the numbers there, so let's say that A's value is 3 and B's value is 8. Okay. How would you find the length or the distance between those 2 points? You subtract, right? You take, most of you are probably going to take 8 minus 3, right? And that's going to give you 5. That's fantastic. But if I do 3 minus 8, what's that give you? Negative 5. It's still the same 5, isn't it? So something we've come across that no matter how I do subtraction, it's always going to give you the same numerical quantity. The signs just might be different. You might be on the wrong side of 0, 0. So if I do this, does that make this 5? Does that make this 5 as well? So as long as it takes after the order of subtraction doesn't matter. As long as it takes after value, I know distance has to be a positive number. We've talked about that a lot. You know. Okay, so if I just use arbitrary numbers in, so let's say that I get rid of my number line. Maybe not get rid of it, but just show no numbers. Now instead of 8 minus 3 or 3 minus 8, now it's going to be B minus A, isn't it? That's going to be the length of that distance right there. Is that okay with everyone? Okay. So when we're dealing with horizontal or vertical lines, okay, we can find distance just by subtracting the coordinates. If I want to do this, this might make a little bit more sense to what we're going to do here in a moment and what we do tomorrow. Let's call that x1. And let's call that x2. Because those are x values, right? Okay. So could I call this x2 minus x1? Okay. Now here's the whole, maybe you've heard me say this before, here's the whole idea about the subscript numbers, the 2 and the 1 on those x's. They are identifiers. They do not have any algebraic property to them other than an identifier. Okay, so it's like if we had 3 Devins in here, okay, I would probably want to use last names when I talk to a Devin, right? Okay, so that I know everybody's looking or talking to the correct person. So I got multiple X's up there, and the 1s and the 2s are subscript because first and last name. Okay, the X is first name, the subscript is last name. So it will be differentiated. Is that okay with everybody? There's no algebra you have to do with those subscripts. All right, so here's my question then. Let's get these axes back in here. And what if I want to find the length of that segment? Okay, I can't just subtract the x's and now just subtract the y's of those were pairs, right? Okay. But a mere fact, let's try to do it. And this is what I like about Algebra, is it allows some of this stuff to be visualized pretty easily. That length is 6.71. If I just subtract the x's, I'm going to get that distance right there, and that is 1, 2, 3, 4, 5. That's 6 units. So just subtracting the x's doesn't give me the distance from A to B. It gives me something shorter, right? And if I just subtract the y's, you see that I just get 3, which is obviously shorter than 6.71, right? So there has to be something different. And because that non-vertical or non-horizontal line A to B has a vertical component to it and a horizontal component to it, that's going left and right and up and down to some extent, right? We have to incorporate the x's and the y's here. Okay, we have to incorporate both those distances. So, here's my question to you. We're going to look at AB, no matter where it's at. Okay, let me get rid of the distance here. no matter where A and B are, no matter where these points are, as long as they're not horizontal to one another or vertical, okay, because there's an easier method then, that is always going to be, let's see here, I'll do it this way.
So if I look at the red dotted line, okay, A to B, would you guys agree, no matter where I put A and B, and where they're at right now, that it is a hypotenuse of a right triangle? There's a blue line and that orange one, BC orange. If we look at those, they are one's horizontal, one's vertical. It's got to be a right angle. Okay. If I move B over here, can I still drag some points and stuff like that to where it's still A to B is still a hypotenuse? Okay, so here's my question. How do I find its distance? What is the number one theorem you remember from the previous 5-6 years of math in regards to right triangles? Pythagorean theorem, right? You know that A squared plus B squared equals C squared, right? Okay. Now I'm not gonna call them A, B, and C. I'm gonna call this one AC. I'm gonna call this one BC. And I'm gonna call this one AB. Okay. But if I square that one, add them together, should give me that one squared, right? Okay. So let's just kind of write that over here. A squared. I'll do it right this. AB squared is equal to AC squared plus BC squared. Okay. Now remember, we're looking for AB. So I don't know what that is. I'm not even gonna mess with that. I'm gonna mess with this stuff over here because we know what it is. If I let this point here be x1, y1, and this point be x2, y2. Okay. I should be able to now, with those ordered pairs, x1, y1, x2, y2, be able to identify with ordered pair C. What is the x value for C? Isn't it the same as what the x value for B is? They're around top of each other? So it's going to be x2. What is the y value for C? It's going to be the same thing as A's y value. Now you have AC's ordered pairs, right? You got the endpoints of those. And AC is what kind of line? Horizontal, isn't it? Okay. So if it's horizontal, all I've got to do is take the x coordinate of x2 and the x coordinate of x1. So that blue dotted line is going to be the same as that distance right there, isn't it? How do I find that distance? Take x2 minus x1, don't I? Okay. Now, I should be taking absolute value of that, so it's positive. But then I'm going to square it. Okay. Think about this. There's some redundancy right there in that algebra. What is squaring something going to do? It's going to make it positive anyways, right? So if I do x2 minus x1, I got negative 5, and then I square, I'm going to get 25, right? And I'm worried about the square part of it, so I don't really need these absolute value bars. And that's a lot of times a textbook will write out x2 minus x1 in absolute values, and then they'll square it, and in the next step, the absolute value bars disappear, and you have no idea where they went. And it's because of that redundancy feature of absolute value and squaring, always making the value positive regardless. Now, I have to get rid of the absolute value, or I'm allowed to get rid of the absolute value and keep the square, but I'm not allowed to get rid of the square and keep just the absolute value. Does that make sense? Then I don't have that magnifying process of the square. How am I going to find BC? I'll find that blank. BC squared. Yeah, y2 minus y1. And the order there doesn't matter because you're going to square it. So if I get like negative 5 and I square, I get 25. I get a positive 5 and I square, I get 25. Okay, that doesn't matter. Y2 minus y1 or y1 minus y2. But now, you now currently have with your AC squared, looks like you have this as x2 minus x1 squared. You now know BC squared is exactly right there. Add to it y2 minus y1 squared. And that should equal AB squared, right? I haven't done anything to the left hand side of the equation. When I'm trying to find the length of AB, am I looking for AB squared or am I looking for AB? I'm looking just for AB, right? So how do I get rid of that power of 2 right there? Take square root of the left hand side, gives me AB. Square root of the right hand side, it gives me x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. Okay. And what that allows us to do, that's a shortcut formula for essentially the Pythagorean theorem with the first point. That's all this formula is the Pythagorean theorem. Okay? That does all the algebra and everything that we need to do kind of instantaneously as we plug it in. Okay? And that's what formulas are all about, guys. This class, you're going to learn some things that you learned last year, and you learned the year before. So we're going to view them from a different perspective. Okay? You've learned to use this formula. You've done countless, endless problems with it. Okay? I want you to learn it this way. I want you to be able to remember this formula for the rest of your life, and that's important to do that. Also, once you understand why. Why, when I'm in a physics class, why, when I'm in a calculus class, do these formulas work? Every time you get a formula, there's logic behind it. Okay? There's reasoning behind it. Now, sometimes it's a little bit backwards. I think sometimes math is backwards because you were provided that formula following the 8th or 9th grade. We're now juniors and seniors, maybe realizing for the first time why it works. Because now you currently have enough math underneath you to see why it works. Makes sense? So when I give you formulas, if we have enough math and it's feasible for us to see why they are what they are, to prove to us, that's an outright proof for that formula, we will do those things. Okay? But there's also going to be times where I give you a formula and it's 2 years from now, 3 years from now, that you'll have enough math background to really understand where that comes from. We won't prove those, and I'll make sure that we understand why we won't do those. Okay? Same reason, I think this full thing shows you guys the opposite b equals minus squared, b squared minus 4ac of 2a. When I showed you where that came from, you can do that. Clean the square with ax squared plus bx plus c equals 0. Okay? Obviously, the formula that you learned early on in your high school career, but it's not 2, 3, 4 years later that you really understand. Website is not working right now. We don't have codes, so no homework this evening. Have a great rest of the day. Don't get too warm.